Today we are going to talk about reflections. So reflection is to flip a figure over a line. So basically what we're doing is we're taking some sort of image and we're flipping it. So if it's over here on the right side, we might be flipping it to the left side. Or if it's up here on the top, we might be flipping it down. Okay? So what you got to think about, if I think about like reflection, I think about it in like a mirror. If I'm looking in the mirror, what I see in the reflection is different than what others would see looking at me. It's kind of the opposite. So that's when we think about it. If something's on the right side, it's going to be flipped to the left. If something's up, it's going to be flipped down. So let's look at the steps to reflecting. So first off, we are going to be looking at this one, reflecting over the x-axis. So I'm actually going to highlight that we are flipping it over the x-axis. And then on my drawing here, on the coordinate plane, I'm going to highlight the x-axis. So I want you to do that because when we start flipping between the x and the y, sometimes we make mistakes and flip over the wrong one. So if I'm highlighting it here, that means that the image on top here needs to flip to the bottom. So first thing I'm going to do is I'm going to write the ordered pairs of the original image. So point C is at 4, 9. Point U is at 8, 5. B is at 8. Let's say that that's actually right here, 3. And S is at 4, 1. So we've written the original pairs. Now we're going to count the distance from one of the points to the x-axis. So I'm going to start with point B. If I count from the x-axis, it's up 1, 2, 3, 4, 5, 6, 7, 8, 9. And then step 3 says that we are doing the opposite, placing a new point on the opposite side of the x-axis, the same distance away. So this was 9 above, so I'm going to count and go 9 below. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to label it C with a little tick mark next to it to show that it's the reflected point. Okay. What is the ordered pair of that point? It's at 4, negative 9. Okay. Point U is 1, 2, 3, 4, 5 above, so we're going to count from that same point, go 1, 2, 3, 4, 5 below. Again, I'm going to put a U with a little tick mark next to it, and that is at 8, negative 5. Point B is 1, 2, 3 above, so it's going to be 1, 2, 3 below. And that's at 8, negative 3. And then point S is 1 above, so it's going to go 1 below, which is at 4, negative 1. And then just like we did before, we are going to connect these points in order. So it goes C, U, B, S. I try to make them spell out words so it's easy to connect. Spells Cubs. I'm going to connect C to U, U to B, B to S, and then S back to the beginning of the C, which you should do with a ruler to make sure it looks nice and straight. So now I want to look at this. We've got a reflected image. We've got the same image on top flipped over to the bottom. If we look at this image and then we look at these different values, compare the x values. So we've got our x values here on the original to the x values of the reflected image. What do we notice? For C, we've got 4 and 4. U is 8 and 8. B is 8 and 8. S is 4 and 4. So if I look at those, I notice that they are the same. So the original and the reflected are the same. Then I want you to compare the y values. So I'm going to highlight here, we've got our y values of the original, y values of the reflected. So for C, I have 9, negative 9, 5, negative 5, 3, negative 3, 1, negative 1. So this time they aren't actually the same. Sometimes people point out and say, oh, it's the negative version. Well, really, yes, in this case it was the negatives, but really it became the opposite. 9 became negative 9, 5 became negative 5. So I'm going to say that they are the opposites. So that should be true every single time when you are reflecting over the x-axis. Our x values are the same, our y values become the opposite. So if we think about it, our image flipped up and down, okay, and the reflected ordered pair, the x stays the same, the y becomes the opposite. So I'm kind of writing the opposite of y there. So we say the x value stays the same, and the y value becomes the opposite. So we looked at flipping over the x-axis. Now let's look at flipping over the y-axis. So again, first thing I'm going to do, I'm going to highlight what it's asking me to flip over. It says to flip over the y-axis. So then on my image here, I'm highlighting the y-axis. So before we had the x and it went up and down, now if we're flipping over this axis, whatever's on the right is going to flip over to the left. So just like we did before, we're going to write the ordered pairs of the original image. So again, I spelled out a word, bake. So we're going to start with B, that's at 0, 1. A is at 3, 8. K is at 9, 9. E is at 4, 6. All right, now we are going to flip it over the y-axis. So this time, we're counting to the y-axis, how far away it is, and do it the same distance in the other direction. So point B is right on the y-axis, so it's actually 0 away, so we're actually not moving it. Our reflected point is going to go right in the same exact spot. So I'm writing B prime. So the ordered pair for that is 0, 1. All right, moving on to A. A is 1, 2, 3 to the right, so we're going to go 1, 2, 3 to the left, and that's at the ordered pair -3, +8. K is 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right, so we're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 to the left. That's at the ordered pair, -9, +9. Point E is 1, 2, 3, 4 to the right, so it's going to be 1, 2, 3, 4 to the left. And that's at the ordered pair, -4, +6. And just like before, I'm going to connect in order, so it should go in the order B, A, K, E. So I'm going to connect B to A. I don't have a ruler on me, but you should use a ruler. A to K, K to E, and then E back to B. So it should look like the same image, just flipped over, right and left. All right, so just like we did before, let's look at our X and Y values. So if I look at the X of the original compared to the reflected, 0, 0, it stayed the same. 3 became -3, 9 became -9, 4 became -4. So this time our X values didn't actually stay the same, they became the opposite. Then if I look at my Y values, 1 became 1, 8 became 8, 9 became 9, 6 became 6. So this time our Y's stayed the same. So they are the same. So our X values became the opposite, our Y values became the same. Now, when we look at making our general rules here, when we're reflecting over the X, nope, this should say the Y-axis, sorry about that. The Y-axis, our image doesn't flip up and down, it flips right and left. Then, our ordered pair, our X value actually became the opposite. Our Y value stayed the same. So X becomes the opposite, Y stays the same. So let's look at two more examples. And these ones get a little bit trickier because now they're overlapping the axis. So it's not just like, oh, the positive becomes the negative. Okay? So example 3, reflect over the y-axis. So first thing I'm going to do is I'm going to highlight what I'm reflecting over and highlight it on my grid. So remember, if it's the y-axis, anything that's on the right is going to flip to the left. Anything that's on the left is going to flip to the right. So let's write our original ordered pairs. H is at 2, 6. A is at 2, negative 9. W is at negative 4, negative 3. K is at negative 2, positive 1. And S is at negative 4, positive 4. So let's reflect, starting with H. H is 1, 2 to the right, so we're going to move it 1, 2 to the left. Our A value is 2 to the right, so we're going to move that 2 to the left. Our W is 1, 2, 3, 4 to the left, so we're going to do 1, 2, 3, 4 to the right. Our K value is 1, 2 to the left, so we're going to do it 1, 2 to the right. And then our S value is 1, 2, 3, 4 to the left, so we're going to go 1, 2, 3, 4 to the right. Okay, then be careful when you're connecting the points. Remember, go in order. Hawks, H-A-W-K-S. H connects to A connects to W, W connects to K, K connects to S, and then S connects back to H. So I can look at the coordinate grid to write down my ordered pairs, or I can use the rule. When we reflect over the y-axis, our y values stay the same. 6, negative 9, negative 3, 1, and 4. And our x values become the opposite. 2 becomes negative 2, 2 becomes negative 2, negative 4 becomes positive 4, negative 2 becomes positive 2, negative 4 becomes positive 4. Okay, example 4. We're going to reflect the image over the x-axis this time. So, remember, x-axis, anything on the top flips to the bottom, anything on the bottom flips to the top. So, original ordered pair, we've got 8, 6 for B. We've got 5, negative 3 for A. We've got 2, 2. So, B is 1, 2, 3, 4, 5, 6 above, so it's going to be 1, 2, 3, 4, 5, 6 below. A is 1, 2, 3 below, so it's going to be 1, 2, 3 above. And Y is 1, 2 above, so it's going to be 1, 2 below. And then it connects in the order B, A, Y. So B connects to A connects to Y connects to B. And then again, we could look at the grid to write down our ordered pairs, or if I flip over the X, our X stays the same, and our Y's become the opposite. 6 is negative 6, negative 3 becomes positive 3, positive 2 becomes negative